Hi everyone. Today we're going to be talking about how to rationalize a denominator. When we have fractions like 1 over square root of 5, this square root of 5 is irrational. And we might want to place it in a more convenient form by having a rational denominator. So the standard technique is this. If you have something as simple as the square root of 5, you take the 1 over square root of 5 and you multiply both the numerator and the denominator by the square root of 5. And that's acceptable because this thing here, this fraction square root of 5 over square root of 5 is equal to 1. So we're just multiplying something by 1, which leaves just 1 over square root of 5. And this whole thing is equal to square root of 5 over square root of 5 squared. And that is equal to square root of 5 over 5. And as you can see, we have turned the denominator into a rational number. Now to be clear, we can't always use this technique for any irrational number, say pi or e, but it does work with square roots. Now the next question we can consider is, what about a denominator like square root of a plus square root of b? Let's see what we can do in that case. We'll be needing a certain factorization called difference of squares. And what that says is that x squared minus y squared is equal to x minus y times x plus y. It might seem a bit weird because we have 2 terms here and 2 terms here, so there should be 4 terms here, but there's some cancellation that leaves only 2 terms, which is why this identity is famous. There's a particular form of this that we're going to be using, which is that square root of a plus square root of b times square root of a minus square root of b is equal to a minus b, and that's for a and b in the non-negative reals. So let's test out this identity on rationalizing the denominator. Let's say we have 1 over square root of 2 plus square root of 3. Then what we're going to do is multiply both the numerator and the denominator by square root of 2 minus square root of 3. What that gives us in the numerator is square root of 2 minus square root of 3. And in the denominator, by difference of squares, we get 2 minus 3. And that's equal to square root of 2 minus square root of 3 over negative 1. And that's simply equal to square root of 3 minus square root of 2. So in this case, we actually eliminated the denominator altogether. But there is a secret division by 1 here, and this is rational. Let's take this one step further, just one more step, to a denominator that has 3 square roots in it. So let's say we have something like 1 over square root of 2 minus square root of 3 plus square root of 5. The technique I'm about to show you it's going to work for no matter what the signs are, like this minus and this plus and the invisible plus over here. It's not going to matter. The idea is the following. Use difference of squares twice. So let's test it out. First, we're going to regroup the denominator. So we get square root of 2 plus square root of 5 minus square root of 3. And we're going to pretend like this is just one block thing. You can call it A if you want, but I'm not going to do that because we're soon going to be getting rid of it. What we're going to do is use difference of squares once, so we get square root of 2 plus square root of 5 minus square root of 3 times square root of 2 plus square root of 5 plus square root of 3 and square root of 2 plus square root of 5 plus square root of 3. Let's expand this out. We get on the top, we get square root of 2 plus square root of 3 plus square root of 5. In the bottom, by using difference of squares on this component and this component, we get 2 plus 5 plus 2 square root of 10 minus 3, and that's equal to square root of 2 plus square root of 3 plus square root of 5 divided by 4 plus 2 square root of 10. One more step after this and then it'll become clear what to do. We have square root of 2 plus square root of 3 plus square root of 5 divided by, we're going to factor out a 2 from the denominator, so we get 2 plus square root of 10. Now at this point you should be able to see what we're going to do. We're going to use difference of squares on this component. So we get, let's actually not expand the whole numerator out. Let's just see what happens to the denominator. So what we're going to do with the denominator is 2 times 2 plus square root of 10. And we could do 2 minus square root of 10, but it's easier to do square root of 10 minus 2. That way we can avoid a negative. And you're going to be multiplying the top by the same thing. I'm just not going to show it. We get 2 times 10 minus 4, and that equals to 2 times 6, and that equals to 12. And that is indeed rational. Okay, so let's do a quick summary of what we did today. We were looking at rationalizing the denominator. I gave you a simple example where you have 1 over square root of 5 and how to rationalize that denominator so it looks like square root of 5 over 5. Then we looked at the possibility of a more complicated denominator where there's a sum of 2 square roots, and we discovered that it can be rationalized using the difference of squares factorization, which is this over here. And I gave you an example here with 1 over square root of 2 plus square root of 3. And finally, we looked at a more complicated example over here where there is a combination of sums and differences of 3 square roots in the denominator. And in the end, we did find out that it is possible to use difference of squares twice to prove that the denominator can be made to be rational. Okay, thank you for watching, and I'll see you next time.